Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video, we are going to build a RAG application using LangChain. So LangChain is an open source framework using which we can build LLM apps. And then the LLM which we are going to use today is we will download that LLM on our local machines. We will download that LLM from Hugging Face. So guys, in my previous videos, I have shown you how to use Google's Gemini LLM. But when we used that Gemini LLM, for that we needed one API key to access that model, right? In the same way, in my another tutorial, I have explained you how to use OpenAI's GPT 3.5 model. But to use that model, we again used a API key, right? So in my today's video, we will download everything on our local machines. We are not going to use any API key for any task. Everything will be there on your local machine, and then we are going to build the app. Okay, so we will download one LLM from Hugging Face, and we are using LangChain, and using RAG we will provide external knowledge to the LLM, open source LLM, which we are going to download from Hugging Face. And then that LLM will answer the questions based on that external data which we provided to the LLM. So let's start the coding part. First thing is to open Anaconda prompt. And here you will create the environment, and by writing this command you can create the environment. After that you need to activate the environment, and you will write conda activate, and then you will write the environment name. So this is the environment name. Our environment is activated. After that we need to install all the packages which are required for today's class. So guys, my today's code is present in this folder, L9 RAG Hugging Face. Here you'll see the requirements.txt file. Let me open this. So these are the all requirements. So now the task is to install these requirements. So for that you will enter in this folder. So it is in E drive, and then I have this folder, and here I have the code. Write pip install -r requirements.txt. Hit enter, and then you will have all the requirements installed in this environment. Now we have our environment and we can learn the coding part now. So for that, if you'll see this folder, we have one Jupyter notebook, and in this Jupyter notebook I have explained the coding part. So let's open this notebook, and for that you will write here Jupyter notebook. So guys, this is my Jupyter notebook. Here first we are loading these few pages, and what we have in these pages, so these pages have data related to budget 2024. So this is the first link, this is the second, then this link. Okay, so on the basis of these 4 or 5 pages, I want my LLM to answer the questions. So we are loading these pages using unstructured URL loader, and then here we are providing the list of URLs which we have mentioned in this list, and then using this load method we are loading it, and just execute it and execute this one. And here if you'll check the length of the data, so here the length of data is 4. Why the length of data is 4? Because we have provided 4 different URLs over here. Now next task is to divide the data into smaller chunks. So which data? The data which we have from these 4 different documents. If you'll print this data, let me print this data once. So let's write data and hit enter. So you'll see this kind of data. You'll see document meta, and then this is the data of first page, first URL. Okay, so like this, if you scroll down, keep on scrolling down, and you will see this is the data we have in this data variable. So here in this cell we are splitting the data into smaller chunks. Which data? The data which we have from all these 4 URLs, we are splitting it into smaller chunks. And the reason why we are splitting it, because when user will ask a question, we only want to pick that portion of the text which is related to the user query. So that's why we have divided the whole long document into the smaller chunks, and the chunk size is 1000. Now after that, I'm printing the total number of documents by writing length and docs. In this docs, we are splitting the documents, and what we are using to split the document, we are using this recursive character text splitter. Using this module, we are splitting the data, and here we are providing the data, and after that we are checking the length, and we are having 164 documents now. Earlier, how many documents we were having? Only 4, because there were only 4 pages in the URLs list. But after splitting, we are having 164 documents. Now guys, if you want to see the content of any document, just print this. Doc7 simply means, okay, so this doc7 simply means the document which is present at the index 7. So this is what we have at index 7c. So we have a smaller chunk of data now. Now once we have that, once you have the data in this format, next task is to perform embedding. Why we want to perform embedding? Because we want to convert this text data into numerical representations. So to convert this text into numerical representation, we use embedding models. And guys, in my previous videos, I have shown you that how to use Google's embedding model and how to use OpenAI embedding model, but to access them we needed an API key. So in my today's class, as I've told you in the beginning, we are not going to use any API key. So we are downloading that Hugging Face embedding model, and then we will use it. So this is how you can import the Hugging Face embeddings. And here we have the Hugging Face embeddings in this embeddings variable, and here we are just writing this line just to check if that model is loaded properly and if it is working or not. So embeddings, what we have in embeddings? Hugging Face embeddings. And embed query, we are just providing this random text to it, and then we are just printing the first 5 values and hit enter, and you will see we have these values, right? So these 5 numbers are the numerical representations, and we got these numerical representations with the help of embedding model. And which embedding model we are using today? Hugging Face embeddings. And guys, if you want to see what are the other options we have, what other embedding models we can use, then you can visit this link, and from there you can see what are the other options we have for embedding models. Now we have these numerical representations. Next task is to store these numerical representations in some kind of database. And to store the embeddings, to store these numerical representations, we need vector database. So here we are using a Chroma database, which is a vector database, and in this database we will store all these numerical values. Okay, so here we are importing the Chroma database. And in this variable, see, this is the one line. Here we are performing embedding on all the documents, and then we are storing those documents, numerical representations, in Chroma database. So this is the variable docs. Remember what we have in docs? So guys, in docs we have all our 164 documents. After splitting our 4 URLs into smaller chunks of data, we got 164 documents, and we have that in this docs variable. We are providing those documents over here, then we are converting those documents, text documents, into numerical representations, and then we are storing those numerical representations in the Chroma database, and we have stored all this work in a vector stored database. Okay, next step is, here we want to use this vector database as a retriever. Now guys, what is retriever? The task of retriever is to retrieve those documents which matches the user's query the most. So guys, if you don't know see here I'm not going to explain this concept in detail because I have covered all these concepts in my lecture of RAG. This is the video, you can check this video. From this video you will understand in detail what is RAG, how it works, right, what is the need of it. From this video you can learn all that. Today we are focusing on the coding part, and I'm just giving you a brief idea that with the help of Retriever we can fetch out those documents which are related to the user's query. So here in this line what I'm doing is I want to use the vector store which I have as a retriever. So guys, we can use any vector database as a retriever. You just need to use this as retriever, and then you can use any vector database as a retriever. So we are using our Chroma database as a retriever, and here we have mentioned search type similarity. So this similarity means it will check the similarity of the documents with the user's question. So user asked a question, let's say user asked this question, budget highlights. So now on the basis of this question, our retriever will search, will find out what all documents are matching with this particular questions, and here we have mentioned the value 3. It means that it will provide you the 3 most matching documents. Okay, out of these 164 documents, your retriever will provide you the 3 documents which matches with the user's query the most. And if you'll change the number over here 6, that means your retriever will provide you the 6th most matching documents as per this user's query. Okay, so this is how we are getting the similar documents. Now we have created a retriever over here. Now retriever.invoke, let's see if retriever is working properly or not, the retriever which we have created over here. So to check that, I have just written budget highlights. So now this retriever should pick the 3 documents from the 4 URLs which we have provided above and show us. So let's enter. Okay, I have to run this also first. So guys, here retrieve documents 3. Now if you want to see the content of any document, so you will write retrieved document, the document which is present at index 0. I want to see the page content of it, and this is what we get. So on the basis of this keyword, this query, this is the first document our retriever fetched, and if you want to see the next document, then hit enter. So this is the second document fetched by our model retriever, and this is the third document as per this query. So this is how our retriever work. Now next task is to use the LLM model, and for today's tutorial we are downloading the LLM from Hugging Face. So for that we are importing all these modules, and then this is the model which we are using, Falcon 7B, 7 billion model. And here in this variable we have written the model ID. So in this text generation pipeline, we are using a pipeline, and we are saying that we want to perform text generation task, and the model we want to use is this Falcon 7B, and max new tokens 400. This means that our model should generate the output which should not contain more than 400 tokens. Device 0 simply means we are using GPU. So in, let's say if you are not using GPU, you can remove this part, or you can write device is equal to CPU. So this is my text generation pipeline. So in this line, so this is a full-fledged LLM over here. This model will generate the output on the basis of the user's query. And then this is our template, prompt template. So guys, why we have template just tell the flow, how the conversation is going to happen. So we have a system and we have a user. So here we are defining how the system will reply and how the user will reply. So for system, answer the question based on your knowledge, use the following context to help. So here we have this one placeholder. What we are going to have in this context? Here we are going to have the retrieved document by the retriever. Remember, we have our retriever over here which will provide you the most matching documents as per the user's query. So that retriever will be the context, and then when under this user we have another placeholder question. Here this placeholder will have the user's questions, whatever user will type in a input box, whatever user will ask to the chatbot, that question, that value we are going to fill over here. So this is our prompt template, and we are creating our prompt template using this over here. See, prompt template, and we have mentioned the prompt template over here, and this context and question I've told you. See, this is context and this is question. So now we are creating a LLM chain. LLM chain, first is prompt. Prompt means user will write a question. That question will go to LLM. LLM will generate the answer of it, and then with the help of this str output parser, we'll see that output in a more readable form. So this is our LLM chain. But what we are making today, we are making a RAG application. Now we need, once we have this LLM chain, next step is to get a RAG chain, to create a RAG chain. So for that we are importing this module, and here, so in this RAG chain, first we are providing the retrieved documents by the retriever, the matching documents, and then we are using the LLM chain. Okay, using this is what we have in our RAG chain. Now let's test if this chain is working properly or not. So I have a question. In this question I've written 2024 budget highlights. So this is the question by the user, and now we are calling the RAG chain dot invoke, and we are providing this question to it. Now when you run this cell, you will see this kind of output. Now let's try to understand this. So guys, if you'll see the prompt template, this template, we have the output in this format. Now first you will see the system, and then you will see the answer the question based on your knowledge, use the following context, and here I've told you we'll get the retrieved documents which matches with the user's query. So let's see if we are having this or not. So here, system, answer the question based on your knowledge, use the following context, and guys, here if you'll see, use the following context to help, and after that our document is started. So this is the context retrieved document. Let me show you. See, use the following context to help. After that we are having the retrieved documents, and how many documents we are going to have? So we have mentioned there 3. So what we have mentioned here, that find the 3 matching documents. Okay, so those 3 documents we are going to have here. Let's see if we have those documents or not. So this is the first document. Document will start like this. Okay, so this is the first document, and from here we are having the second document. Okay, so like this, but here the answer is not clean. So let's refine this answer in the next cell and see what kind of output we get. See, we are just invoking the same RAG chain on the same question, but I'm just performing some step on it so that we can get our output in a more readable form. And if you see the response over here, you can see we have a system, and then answer the question based on your knowledge, use the following context, and then we have these 3 documents over here, and on the basis of this context our model will reply. Now the question which is asked by user was, this is the question which user asked, and then this is the reply by our model. So here let's see, question was 2024 budget highlights. Now let's see what we get. So this is the output. See, budget 2024 key highlights, live update. So here you can study about it. So this is the first output. Now let's try to ask another question. So our question is, what is the union budget? We are invoking the chain, and when you'll hit enter, you'll see guys, we are getting the responses as per this prompt. First system, then this, then context, then the question of the user, and then the reply from the assistant. So let's see the reply. So we have it over here. Yeah, so this was a question, and here response, answer, and then response, then this is the document, 3 documents, then this is the question by the user, and then this is the reply by our model based on the context it took from the those retrieved document. And the reply is here, you can read here. So this is the reply we have. Now let's say if you don't want to use this Falcon 7B model and you want to work with some other model, then so here I have shown you the demo with one more model. So in this case we are using GPT Neo 1.3b. so this model have the architecture like GPT-3. so we are loading this model from the Hugging Face. Now we'll download this model from the Hugging Face, and then we have that text generation pipeline. So we are providing the model, the task is text generation, temperature is 0.1. so guys, temperature simply means what kind of responses you want your model to generate. So you can set this value between 0 to 1. 0 means the more focused answer, and 1 means the more random and diverse answers. So I have set the value over here, this. And then the max new tokens means the output of the model cannot have more than 400 tokens. So here we are creating our LLM using this pipeline which will generate the text. Okay, and now the same template we are having over here, and this same prompt, LLM chain is also same, and then RAG chain is also same. The question is this, and we are invoking the chain, and then you can check the response. If you want to test this model, let's run this model from here. So guys, when you will execute this Jupyter Notebook for the first time, so it will take time because all the models will be downloaded in your machine first, then you can use it. Okay, response, then this is the document, 3 documents, then this is the question by the user, and then this is the reply by our model. So guys, this is how you can provide external knowledge to the LLMs using RAG, so that LLMs can answer the questions based on the external data which you have provided to them. And the link of this code is given in description section. You can try this code. And guys, if you like my content, please like, share and subscribe my channel. Thank you for watching.